Meher,
Yes,
over to
ma'am.
Meher.
Yes. Allow your passion. Ma'am, am I audible, ma'am?
Yes.
Allow your passion to become your purpose and it will one day become your profession. Quote and unquote, Gabriel Bernstein. Good evening to all. It gives me immense pleasure to extend to you a warm welcome on behalf of the Department of Computer Science, Guindy Campus, University of Madras, who has clubbed all of us for the 2-week workshop on analytical tools for image processing, organized by Department of Computer Science, University of Madras, as part of MHRD RUSA 2.0 Biomaterials. I would like to welcome respected professors, honorable speakers, research scholars, industrialists, and students from various departments. The focus area of this workshop is nanotechnologies, cancer imaging, orthodontics, and orthopedic and nanoinformatics with hands-on training on predictive analysis tool and case studies. Eminent speakers from industry and research organizations and academicians from national and international reputed institutions are handling various sessions on this informative workshop. Today, we are on day 6 of this 2-week workshop. Now, I would like to invite Dr. B. Lavanya ma'am, Assistant Associate Professor, Department of Computer Science, University of Madras, and one of the convener of this workshop to say a few words. Thank you, ma'am.
Thank you, Meher. I would take this opportunity to welcome all for the 6th day of the MHRD RUSA 2.0 sponsored 2 weeks workshop on analytical tools for image processing. Today's topic is going to be secure network analytics with deep learning and transfer learning, which we are going to hear from Dr. T. Sendil Kumar, Associate Professor, Computer Science and Engineering Department, Amrita School of Engineering, Coimbatore. Today, on behalf of the organizing committee, I would like to welcome and thank the authorities of University of Madras and our group leader, Dr. Balakumar sir, for being a constant support. Now, let me request Dr. C. Victoria Priscilla, Head PG Department Computer Science, SDNB Vaishnav College, Krompet, to introduce our today's speaker.
Happy evening. To start with, I thank the organizing committee of the workshop, the Department of Computer Science of University of Madras, for giving me the opportunity to introduce the speaker of the day, Dr. T. Sendil Kumar. Learning gives creativity, creativity leads to thinking, thinking provides knowledge, and knowledge makes you great, said APJ Abdul Kalam sir. With this quote, it's a great pleasure and honor for me to introduce our speaker, Dr. T. Sendil Kumar. Dr. T. Sendil Kumar completed his BTech from Computer Science and Engineering from Sedu Institute of Technology, Madurai, and Masters Distributed Computing Systems from Pondicherry Engineering College. He has completed his doctorate in Information and Communication Engineering from Anna University, Chennai. His areas of interest includes video surveillance, deep learning, cloud computing, software engineering, video processing, wireless sensor networks, big data computing, and embedded automation. Sir is currently working as an associate professor in Computer Science and Engineering Department at Amrita School of Engineering, Coimbatore. He has received appreciation in Indian Express for agent-based programming for banking domain. Sir has publications in 9 national conferences, 12 international conferences, and 14 international conferences, and 2 edited book chapters. And he has publications in 19 Scopus indexed publications, and he also published a book on C++. He is a reviewer for Elsevier Computers, an electrical engineering journal, IEEE Access, International Journal of Intelligent Information System, IJA Global, Springer, Data Analysis, International Institute of Engineers Journal, Journal of Electronic Imaging, CMS. He is guiding scholar with Amrita Vidyapeetham in the area of video analytics, deep learning, and signal processing. He teaches courses in video processing, video analytics, distributed system, multidimensional signal processing. He has involved himself in developing competency areas of programming like MATLAB, NS2, JST, .NET, Android, Hadoop, OpenCV, Spark, deep learning tools, embedded automation. He has been working with Amrita Vidyapeetham, Coimbatore since 2001. He is a part of funded projects with IBM, DST, and Ministry of Tribal Affairs. Sir has 2 decades of rich teaching experience, and no doubt he is a man of letters. He has more and more credentials. Due to paucity of time, I limit myself. We welcome you, sir. Over to organizing committee.
Yeah, sir, we are eager to listen to your knowledge sharing, sir. Over to you, sir.
Thank you, ma'am. Thank you so much. Am I audible, ma'am?
Yes, sir.
Okay. So my sincere thanks to Dr. Chitra, ma'am, Dr. Lavanya, ma'am, Dr. Victoria George, ma'am, and other members of the organizing committee to have chosen me to talk to this workshop audience more related to image processing. Right. So today's session, I would actually take you through with deep learning, transfer learning, and we would set the stage for some things to practically start. So that's a plan for today's session. And tomorrow you'll be going more with programming with image processing, again from security perspective. I hope I'll do my best to make everything possible. I'll also share you a manual at the end of the day, which people can practice and they can come in for tomorrow's workshop. So that's a plan. I hope we can set some things learning for everybody. Right. So let's take the things forward. See, the topic I have actually given to the participants is on secure network analytics with deep learning and transfer learning. So there's a lot of experts who have spoken to you till now. So we will set the stage for why are we talking about this and what is the need for it for nowadays, right? See, when you say that there is some data that is being captured, the data that is being captured could be possibly from a camera, and that camera could be a camera which is part of your laptop, or it could be a camera which is possibly a camera which you have kept in a place, or it could be a camera which is able to access something which is on the Wi-Fi. We have got now Wi-Fi cameras are also there. So there are generally 3 types of camera-based applications I know now. One is basically with respect to laptop. Now each one of you are before the laptop. Your camera takes your face and immediately says, "You are so person." This type of data. Other type of data is like you have an IP camera in your room. The IP camera will record the data and it will be able to give you some live analysis. That is where we are using for all the footage analysis. The third type of camera is something like a Wi-Fi camera. It is something like you have a camera. Hello? You have a camera which is being attached to an onboard device, and the camera can record the data and it can send the live feed to your mobile. So your mobile can have an onboard storage. There you can do live processing, right? So this is how you can think of camera in the real space, okay? And once you have a data which is coming from a camera and you want to do some processing, the fundamental challenges that happens is, first one would be what type of data that you're capturing. For example, your image that you capture could be a BMP image, or the image that you capture would be a JPEG image, for example, or your image would be a raw image format. So the first challenge that happens is the type of image that you capture. The second type of challenge that you would happen to come up with basically the motion part of the data.
Screen, sir.
Yes, ma'am.
Sir, screen is not visible, sir.
1 second. I've shared. 1 second. I'll share it again. Yeah. Thank you for saying so. Is it visible, sir? Now?
No, sir.
No, it's actually sharing, started sharing. Now it is visible, sir.
Okay.
Thank you, sir.
Yeah, thank you, sir. Thank you so much. So the data that we capture normally can be an image-based data, or the data can be a video data. Normally with image, you can analyze only as pixels. And when you come to image, what you can together analyze with motion is you can actually capture it as a video. If you have a video data, you can analyze more about the motion of the moving pixels. So today's analysis, more about security, has gone to both the directions. Either you can analyze it with images, or you can also analyze it with video-based content, right? Now, the discussion about here for today's session would be is how can you actually take image data and understand with respect to deep learning and transfer learning. That's a stage that we will set for today, right? So when somebody says deep learning, I think it's more than 3 years plus deep learning is very popular now. In summary, it is something like if you have a data and that data needs to be classified or predicted with high amount of accuracy, you can actually go for deep learning. That's a summary, right? So if your data needs to be classified or predicted with high amount of accuracy, you can actually go for deep learning. There are a lot of deep learning architectures that are there. One example of a deep learning architecture is what I'm putting on the slide, which is CNN, convolutional neural network, right? So what we want to do is we want to take data which is actually as images, and we want to process that data to come back with some sort of analysis. The analysis is more about security here, right? We will come to that later as how are we going to talk about security. Now, when we come to deep learning gives a lot of architectures, but today's session we will take you through with CNN and see an example of CNN architecture. CNN as such stands for convolutional neural network, right? So when you have a deep learning model, the advantage of a deep learning model is you can actually learn the given data, and finally you can have a model file, right? So if I have 100 images, with the 100 images, I can actually create a model file from the deep learning. So deep learning as such will give you a small model which you can use it for that purpose. And the second advantage of deep learning is every time you need not run your program from the scratch. I think people, if you are new to deep learning, please understand this in summary. If I have 100 images, right, and with 100 images, I have created a deep learning model. And tomorrow, I am getting an 101th image for testing. I will not go and run the training process again. All I need is I can take the model file which I have from deep learning and give it to the test file. The test file will be predicted with so much amount of accuracy. This is a second advantage for deep learning. You need not recreate the model again and again, right? Now, when you come to CNN, the concept of CNN says that there is going to be something called as input layer, and there is an output layer on the other side. As we can see here, there is an input layer on this side and there is an output layer on the other side. Between the input layer to the output layer, what you have is hidden layers. In the diagram, you can see that there are 3 hidden layers labeled as hidden layer 1, hidden layer 2, and third is hidden layer 3, right? So the speciality of deep learning is, deep learning says that I will give you architectures, but you will have special type of layers in terms of hidden layers. What is a special type of layers? If you come to CNN, people will talk to you about something called as convolution layer, pooling layer, like that. If you go to certain other architectures, they will talk to you about something called as block layers. So the summary is, between the input layer to output layer, we have hidden layers as part of deep learning. Now, the question here is like, if you are going to take the CNN architecture and consider it for an image, right? How are we going to take it? That's a whole question here. See, when you look at any image, the first question somebody would ask is, how did you understand the image? My answer would be, is I understand it as a lot of pixels, right? Then the second understanding people would ask is, if pixels are there, the image has got many number of pixels, right? If you take this image on the left side, it has got a height and width. So considering the size of the pixel, then I can assume that there are many pixels in the image. So should I learn all the pixels separately? It is not required. So there the answer is, you can learn some features from the image, and that features can be called as patterns, right? So rather than learning the whole image, you can actually learn some patterns from the given image. Please understand this concept. These patterns will actually fall into theory as something called as feature engineering, right? So you want to learn features from the given image. The process is called as feature engineering. So our requirement is we want to run through a feature engineering algorithm, which will actually capture the features from the given image. So there are a lot of feature engineering algorithms like you have SIFT, SIFT, you have SURF, SURF, SURF algorithm, you got Harris Corner algorithms through which you will be able to extract the features of the given image. So in summary, the point I'm keeping to the audience is you can learn image as pixels or you can learn image as features, right? So which feature extraction algorithm I can use, that is your choice. Depending on the nature of the image, you can assume that you want to go for a SIFT or a SURF or a Harris Corner, right? So rather than learning the entire image, we are interested in learning the patterns from the given image, right? So once we learn some patterns from the given image, together when we give it to a model, right? So what the model will do is the model will start learning the features and it will try to detect the features, right? So the question here is like if you have a region of an image, can you have information about the region of the image just with few parameters which can be used for prediction later process, right? Now the question is, in this image, if I have a small detector through which I am able to learn, can I recreate such detectors over the entire image and learn everything from the given image? So a whole lot of detectors will just move around the image, which will allow me to learn the image, right? Now in this example, we have actually taken an example of a bird, right? Now in this bird example together, in the first part of the bird, if I can learn the part of the feature, which we are showing with a red color, the same thing I can actually take it for the second bird and I can compare it with what I have learned from the first bird, right? And I can assume that this is having a different shape, right? But this also has a similar shape with small variations. So the advantage is rather than learning the entire features together, we are trying to compare images together and we are trying to learn features out of it. That's a whole theory here. So this needs to be done properly with proper tuning of the parameters. So whatever parameters with which I have fine-tuned the model for the first image, the same thing I can do it for the second image also where there is a bird, right? So what should have gone to your mind is, okay, if there are images which are in front of me, I can actually use feature extractors. Using the feature extractors, I can extract the features of the image so that if I have extracted some features out of one part of the image, the same thing I can extract with other image and I can compare whether they are falling together or not, right? Now at this point, I'm bringing in one more keyword which is called as class, right? Which is a very primary concept. What is the definition of a class? A class says that if there are more than one instance of the data which shares a common characteristic, they can fall into a class, right? A typical example for our layman thought is if there are 50 students in a class who study BCom, all the 50 students fall under a class called as BCom because they have enrolled under BCom course. The same way, this bird, right, and this bird, as such, they fall into the same class, which is a bird class, right? So our question here is, if I have an image, I'm interested in actually finding out whether it's the same person or not, right, or it's the same bird or not. Then in that case, I can associate it with with a class. This is something called as a classification problem, right? So associating one or more instances of the data to a respective class is a classification problem, right? So the concept of classification will also give you one more keyword called as interclass and intraclass. Now, if I say this image of a bird and this image of a bird is together under only one class, then I will say that I'm comparing this image with this image, right? It is actually an intra-class problem, right? Bird X has got black color, bird X has got white color. There may be a bird X with orange color also. So when I'm comparing all the birds together, I fall it under something called as an intra-class problem. Right? Now, what is an inter-class problem? That can be the next level. For example, if I look at the characteristic of the features, now if you see this bird has got a texture. I can assume that the similar texture will also be appearing in the cloud, right? If I look at the cloud also has a similar texture. So I'm interested in knowing whether this texture features match together or not. If I can find it, then that case, what I have concluded is I'm able to say that I'm comparing bird's image versus a cloud image. So there it becomes an inter-class problem, right? Because I'm comparing a bird image with a cloud image, it is an inter-class problem, right? So your classification problems can be either a intra-class, like what we are seeing, comparing one bird with another bird, or comparing a bird versus a cloud, which is an interclass. So your data that you generate always should have lot of challenges from different class of problems. Reason is, tomorrow when I give a cloud image which has got lot of cluttered pixels like this, it should not say that it is a bird. Okay, so you are the person who is developing the model. The model is intelligent because you are intelligent. So the knowledge developer to the model is only you. So you should actually create lot of images which has got most of the challenges related to the domain of the problem. Fine. So in this context, your layers also will help you more and more when you want to understand the features. So in CNN, you have a convolution layer where you say that you have lot of filters. You know the purpose of a filter. A filter as such does a dot product operation. So where you can actually apply a filter over an entire image, and the filter will give you an enhanced image, right? So a convolution layer will say that if you have an input image, you can choose a filter that can actually apply on the input image and you will get an output, right? So a convolution layer will have more number of filters. So what is a convolution operation? That's the next question somebody would ask. If you take an image as such that can be understood as an RGB image, or it can be understood as a grayscale image. If you take an RGB image, it means it has got red, green, and third what it has is something called as blue. Red, green, and third what you have is something called as blue color pixels. Now if you take a sample image here, which is a 6x6 image, right? So it has got binary values as 1 or 0. Now here we want to apply some filters on the image. So one of the filters is here, one of the other filter is here. So there are a lot of filters that are there in image processing. For example, you have a box filter is there, you have a median filter there, you have a Gaussian filter is there. So you can choose whichever filters that you want, right? So you are seeing some sample filters which are put up here, and left side what you see is an image. Now what you want to do is you want to apply the filters on the given image. You want to move the filter over the entire image and you want to do an operation. So this becomes something called as a convolution operation, right? So what a convolution will do is, if you take this filter, I'm moving this filter over this image, right? So that case, the filter is applied over this image. Please understand, here we are not showing a RGB image. If it is an RGB image, it will have values as 0 to 255, right? So I'm moving the filter over the image. So what it does is, it actually does a dot product. So this is 1 into 1 plus minus 1 into 0 plus minus 1 into 0 plus minus 1 into 0 plus 1 into 1 plus minus 1 into 0 plus minus 1 into 0 plus minus 1 into 0 plus 1 into 1, right? So it does a dot product and you get a result. So the result that you will get here is 3. This becomes the first pixel value that you want to do. Now what you do is you take the same filter, you move the next 3x3. You will again do a dot product. You will get a value as minus 1. Same way, you can actually move the filter over the other image. Now when you do this, what you get is you do a stride operation. Okay. So what is stride is? Stride says how many pixels you can actually shift at a time. For example, in this case, you are shifting 1 pixel, right? You are moving the filter over the image. You shift 1 pixel, you move the filter over the next 3 cross, right? But instead, you can actually increase the stride also. When you say stride equal to 2, what happens is, first time you move the filter over the first 3 cross 3, then when you say stride equal to 2, you shift right 2 pixels and then you move the filter over the next 3 cross 3, right? So stride corresponds to how many pixels you want to shift. Now somebody would ask a fundamental question, should I follow stride equal to 1 or should I follow stride equal to 2? It depends on the size of the image. For example, if you have an aerial image where the size is so larger, you cannot actually say stride equal to 1. You will say stride equal to 2, 3, 4. It depends on the size of the aerial image that you work. Right? So convolution operation in summary will allow you to move the filter over the entire image, and what you have is a convolved image like this. And the next conclusion here is the number of pixels that you get in your convolved image will be less than the number of pixels in your original image. Right? Okay. Now convolution is completed. Now, as a result of convolution, your enhanced image is now available for you. So what we are trying to show you here is, on applying the filter, the resultant pixel values, right, are equivalent to the values that you are supposed to get from the row-wise matrix. Okay. The same thing will be repeated for all the filters, right? For all the filters, you will try to have your individual convolved values. So if you can see here, after doing convolution of the filter 1, right, this is filter 1 on the original image, this is your resultant pixel value. Now you are taking filter 2, move over the entire image, you get a new set of pixel values, right? So number of filters is your choice. Based on your number of filters, you can actually have enhanced image at every step. This will give you something called as feature map. So what you got in your feature map? From your input image, you have learned a set of features, and that features are right now available for you to represent and understand. And this feature map has the characteristics of the original image, right? Okay. So in this case, if you can see here, we have got at every step, we got 4 cross 4. At filter 1, you got 4 cross 4. At filter 2, you got 4 cross 4. So finally, what is the size of your feature map? It is 2 into 4 cross 4 matrix, right? So the size of the feature map now is 2 into 4 cross 4. Now the same thing, if you are taking it for an RGB image, so you have a red, you have a green, you have a blue. So what will happen here? For each of the red, green and blue, you will again apply filters. But filters, again, you will not have only one filter, you will have 3 filters, because one for red, one for green, one for blue. If you're going to use 2 filters here, filter 1 will have one for red, one for green, one for blue. Filter 2 will have one for red, one for green, one for blue, right? Now, when you actually start understanding this more better, you will be able to come to a conclusion saying that if I have an image, if I apply filters using convolution operation, what I get is a feature map, right? Okay. And this is part of a very important operation in terms of CNN. The other one that you get here is something called as fully connected. Now, if you see here, whatever you learn from here, that's a feature map, becomes the resultant part from your fully connected layer here. Right. Now, take a 6x6 image. Now I'm applying. Now, we have done a convolution operation. Convolution is successful. After doing convolution operation, what you can do is you can actually take pixels, right? And you can understand which pixels are having dominant features, right? The pixels which has dominant features, right, can alone be connected, and you can generate a feature map as like this. You can see here, right? Okay, so Now, once you've done your convolution process, right, you can actually do your pooling. What you do in pooling is you take 2 cross 2 and take the maximum value out of the 2 cross 2, right? For example, if you take the first 2 cross 2, 3 minus 1 minus 3, 1, 3 is highest. So you pick 3 and put it in the pooling operation. Now you take the next 2 cross 2, minus 1 minus 3, 1, 0. Highest is 1. You take 1 and put it. So the purpose of pooling is, pooling as such will allow you to have data being provided, and second advantage is it will allow you to do a downsampling on the given date, right? So what you see in this slide here is, this is your original image, this is your feature map after applying filter, and this would be a representation values with respect to the input data. Input data here in the sense you can take it from your 1 0 0 0 0, right? And again, if you come down 0 1 0 0, start expanding here, right? Okay. So finally, a CNN as such will say you can actually do convolution. What is convolution? It's a dot product. What is pooling? You take every 2 cross 2 pixel value, take the maximum value out of it. It is actually a pooling operation, right? So a CNN as such will actually say that you can actually do convolution, you can do pooling, and this can repeat again and again, right, as part of your convolution neural network. So when it repeats again and again, it falls into something called as an epoch, right? It falls into something called as an epoch. So your convolution and pooling together will fall into something called as an epoch. Now, this is what we have been saying in terms of max pooling. You actually take an input image, you can apply pooling operation, you can take either every 2 cross 2, and you can take the maximum value out of it. So you take this 2 cross 2, maximum is 3, right? Similarly here it is, maximum value would be 0, here it will be 3, here it will be 1. Same here, okay, 3 0 3 1. Similarly here, this is your original pixel values. So maximum is minus 1, here it will be 1, here it will be 0, here it will be 3. So the purpose of pooling is to take which pixel value is highest among the group of pixels. That is, every 2 cross 2, which is highest is being chosen here, right? Okay, why do we do a pooling? As I told you, a shortcut or short quick summaries like pooling as such will allow you to do downsampling on the given date. But why are we insisting pooling? The reason is, when we do the subsampling, the original data will not change. Suppose I have a bird, I am doing a subsampling. Right? Subsampling in a sense pooling. What are we doing in pooling? We are saying every 2 cross 2, we are going to take only 1 pixel value. Though we are taking 1 pixel value, that pixel value will hold the entire information of the 4 cross 4. So, in quick understanding, if I have a bird image, if I'm going to do a subsampling out of it, it's going to be again a bird image only. It's not going to change at all. So the information in the given data will not change, right? So all we are trying to do is we are trying to reduce the size of the image by retaining the original information in the image using pooling, right? So in summary, it is like we want to use less number of parameters to characterize the image. So CNN as such generally does all this together. First, it reduces the number of connections. And second important thing is it gives you shared weights on the edges, right? And third is like, since we are going for max pooling, the size of the image gets reduced. So the complexity of operation also gets reduced. Okay. So this is the summary that we have been trying to say. Input image given to convolution, right? Convolution is a dot product operation with a filter. Then you give to a max pooling, you get a resultant image, right? So the newer image is same as original image, but it is smaller than the original image. Okay, it's smaller than the original image. And the next information, if people are new, it is like every filter will fall as a channel, right? Here we are saying 2 filters that we have used. That means we have got 2 channels. Now, if you look back into your CNN, what are we saying? Group of convolution and pooling together will give you a new image. Again, I am repeating the convolution and pooling, right? Then again, I will get a new image, which is originally lesser than the available image that we got in the first epoch, right? Okay. So this is the summary that we are trying to teach to all of you. Input image given to convolution and pooling will repeat for many number of times, and we will be able to learn the given image. So next is something called as flattening operation. If you look at this image values that we get, right, after doing a pooling operation, this is your resultant image. This is your operations that we want to do. We want to do a flattening here. So what happens with respect to flattening is the original data as such will remain the same, but it will actually binarize the data over the entire image. Right. Now let's come to the discussions with respect to theory and practical part. If there's any questions, please post the questions in the chat box. Now, to get a quick summary of what we have been trying to do, I'm opening the browser. Ma'am, are you able to see my screen?
Yes, sir, it's visible.
Okay, right. So playground.tensorflow.org, right? This is a quick URL for everybody to get an understanding of what we have been trying to explain, right, from deep learning perspective. So deep learning says that you can run your model for many number of epochs, right? You can run your data for many number of epochs, and there are some things called as hyperparameters which are available in deep learning, and there are something called as parameters. Hyperparameters are one which is being set by the model developer. Parameters are one which is being learned by the model, or which is being evaluated by the model. So example of hyperparameters are learning rate, then you can see activation function, regularization rate, then you have regularization type, as you can see L1, L2, right? All these are examples of hyperparameters because they are set by the model developer. Certain parameters are estimated by the model, like test loss, training loss. All these are examples of parameters. So every deep learning architecture will give you a set of hyperparameters and parameters. Now come to your data. We are saying deep learning is very important for applications. Reason is, wherever you are not able to find a hypothesis, now look at this data. No, there are two classes, at least for understanding, one in orange, another in blue. Fine. Now, even in this case, if you see here, I'm interested in finding out a hypothesis which will separate this data from one another. It is not possible. Okay, but deep learning says that I will give you kernels, I will give you activation functions which are non-linear, through which I will be able to classify the data, right? So wherever there is lot of uncertainty, here there's lot of uncertainty, I don't know how to split this data at all, then deep learning is a good choice. Okay, so you can keep it to your learning, all the participants. Deep learning is for problems which has got lot of uncertainty. The next one is ratio of the training to the testing data. How much percentage you want to give for training, how much for testing? You say 70% for training, 30% for testing. Do you have any noise in the data? Do you want to give a batch size? When you say batch size is 20, right, that means we are saying that we are not giving all the data as one stretch. We are taking every 20 size of data and we are giving it to the model. So next is features. As I told you, the model will learn the features, and at every layer you will have a set of neurons, right? Every layer you can have your set of neurons. You can have hidden layers as per your choice. Here there is a difference in deep learning. Deep learning says that at every hidden layer you can actually have your own number of neurons. For example, here you can see that there are 5 neurons we are using, whereas in the next one what we are using is we have got only 2 neurons. But whereas when you go to neural networks, the challenge is the neural networks will say that all the layers should have, that means all the hidden layers should have the same number of neurons. Please understand the concept. All the hidden layers should have the same number of neurons in neural network. Deep learning is not like that. Each hidden layer can have different number of neurons. So the next important thing here is like whenever you want to learn your data, you can run it for more than one epoch. When I say one epoch, it means one forward propagation and one backward propagation. Please understand, one forward, one backward propagation, right? But in deep learning, what happens is once it is going to the second epoch means what? One forward, one backward, and again it's going. The weights that are provided, all the weights will not be used in deep learning. I'm again repeating, at every epoch, all the weights will not be used in deep learning. But in the case of neural networks, all the weights will be used in deep learning. All the weights will be used in neural network. So the difference is the deep learning architecture will be able to know which weights are essential to improve the learning, to reduce the loss. Based on that, those weights alone will be chosen by your deep learning architecture. So in summary, a deep learning architecture at every epoch will choose only the weights that has participated to improve the learning capability of the model. And epoch, you can run it for any number of times, and more the number of times you will run, automatically the model is stable model. Okay. This is the first thing that you should know from the theory perspective of deep learning, data, and so on. Now the next question somebody would ask is, okay, I also want to do something with deep learning into security. I would like to run some models with respect to image processing perspective, right? So here, the next question somebody would ask is, I need some data set. There are a lot of data sets that are there. Primary data set which I will suggest for deep learning would be into Kaggle. You have a lot of data sets from Kaggle. You can use data sets from Kaggle for doing your projects or research. Then the next type of data set which I would suggest is something called as outlier data set. Outlier data set. If you go here, you will get a data set link from Stony Brook, which will have a lot of data sets with respect to outliers. This will have image-based data set also, right? So one is from Kaggle, and next, which I have given you, is with respect to outlier data set, right? Other than this, the popular data sets that are there is one is called as your Caltech data set. Next data set is Caltech data set. This is also a very popular data set. So here also you get a lot of images, and the advantage here is you'll get images which are 360 degrees. That means for every object, you will have 360 images for the object. Okay, so if you want to work on data sets where you have a lot of challenges to be available, you can always use Caltech dataset also. So this is second thing which I want everybody to know about, some data sets that you can use for your projects or research related to image part. Right? Now, next to be understood is the implementation part. I also want to do a code. I also want to make a model. That's an interest of everybody. So there, one, you can actually use programming language as Python. Right? You can have Python as an open source library code. The next one is you can actually use a library which can be Anaconda framework. Next library that you can use would be a Anaconda framework. Right? You can use Python. You can use Anaconda framework. Right? Now, when you do both of this, you will get two editors. One editor is called as Spider. This is like a editor in Windows. Like if you have worked in Eclipse, what you do is you'll open a code, run the code, see the output. Similar lines, you will have something called as Spider, right? Then the next editor that you have for your reference is Jupyter. Next editor that you have for your reference is your Jupyter editor. Jupyter as such is an online editor, right? And the advantage of Jupyter Editor is it will allow you to run Python notebook files, right? Certain times when you go and see internet here, so it will actually say you that it is not just a Python file, it is Python notebook file, right? So you will have Python notebook files, which is nothing but IP and this is Python notebook file. So you can use Jupyter to run Python notebook files, right? Okay. Then together, when you want to work with this and do a lot of analysis, because once you want to present your results, then naturally you want to show some graphs. So there you can actually use Matplot, right? This is the other one that you can use for visualizing the graphs. There's one more library also people use, which is called as Seaborn. Okay, this library is also come up. This is about the softwares, right? Now, if you ask yourself the summary of softwares, you would say you can have Python, Anaconda. You can either use Jupyter or Spider. For analysis, you can use either Matplotlib or you can go for Seaborn, right? Now, the next question is people will ask, okay, I also want to do something related to this. I have already told the participants to install Anaconda software and keep it for your reference so that it is giving you more support, right? We will come to that part now. Now, the next one would be is like we need programming frameworks to work with deep learning. The popular frameworks that are there are one is called as Keras is there, TensorFlow is there, then you have Theano is there, PyTorch is there, right? Each of these frameworks, if you ask a question, what is the advantage? It's very simple. Each framework has the set of libraries to work with image processing, right? But if you ask the technical difference, okay, what is technically different between one programming framework and other programming framework? If you come to TensorFlow, the implementations are created with C++, okay? And it is still an opinion from the research community that C++ is more better compared to Python. Okay, so TensorFlow implementations are having library codes implemented with C++. That's the only difference, right? Now, let's take the same CNN and start asking us, okay, we would like to use Keras. How does architecture works? Then in that case, what happens is your network architecture in CNN is what? Convolution, pooling. So stack of convolution and pooling layers. So the input format would be a vector, which is a 3D tensor if you go to Keras. Right. Now, how does this look like? Your code will start going like this. You will have a model file name dot add. I'm talking about Keras. So convolution. There you will specify the image parameters and the shape of the con. Right? This are together is a filters that we have seen earlier. If you can remember, no, we said every time when we do a convolution, we actually apply a filter. So what is the meaning of these three parameters? It says I'm using 25 3x3 filters. We showed you in the slide with an example of two 3x3 filters. If you're going to use 25, you would say 25 3x3 filters. Okay. Now, the next one that you can find is a shape. Here we have specified as 28, 28, 1. Here we are saying the shape of the image as such as having 28 cross 28 pixels. Right? So here, one as such that we specify means it is black and white. If you say 3, then we say it is RGB. Since we are working with a black and white pixel here we are specifying it as 1. So in all the codes that you're going to see in CNN, in Keras, you will see the first part, which will actually be the shape, which is pixels, right? And next, if you look at the 25, 3, 3, this indicates it is 3x3 filters. The total number of filters is 25. Okay. Now, the next one that you can find is with respect to pooling. How would you write a code for pooling in Keras is like this. Model name dot add max pooling 2D. Within bracket, you will write it as 2, 2. So what is this 2, 2? We told you already, no? The purpose of pooling is to what? We want to take every 2 cross 2, take the maximum out of it and use it. So here the inner parameter will be 2, 2. So what would happen here is, if I have values as 3 minus 1 minus 3 1, we will get it as 3, right? Okay. Now your network architecture will go like this. Here it will be 1 cross 28 cross 28, right? So what is this? We have already told you. 1 is nothing but your black and white, indicating the type of image is black and white. 28, 28 would indicate your number of pixels. So this would be 1 into 28 cross 28, and this as such, when it is given to pooling, we would have it as 2, 2, indicating we want to take every 2 cross 2 pixels. Okay, right? Now this given again, what will happen? It will get subsampled and you will get lower dimensions of the image. The reason is, when we do a convolution, we will get it as 25 cross 25, 26 cross 26. When we give it to pooling, we'll get 25 cross 13 cross 30. Again, when you give it to one more convolution, we'll get it as 50 cross 11 cross 11. Again, when you give it to pooling, it will further reduce it to 50 cross 5 cross 5. This is just a diagrammatic representation to understand. If you have 2 stack of convolution pooling layers and assuming the image size to be 28 cross 28, what will happen to the size of the image, right? So how many parameters do we need for each filter here? Here as such, we need 9 parameters because we are given it as 25, 3, 3. And how many parameters do we need for each filter here? Again, it will be as 25, right? Because it has to take value from here. So it is 25 into 9, which will be 225, right? Now, this diagrammatic representation becomes better. Input image, after convolution, after pooling, again convolution, and again after pooling, right? Now you give it to the flattened operation. When you want to do the flattening operation with respect to Keras, right? What happens is you will use the code as model name dot add of flatten. Model name dot add of flatten. This will be the function that you will use here. Now again, when you go to the next step forward, your model will be created and you have a pre-trained model which is now available in Sienna. So in summary, now you know about how the input data has to be represented, and if the input data has to be represented, what are the parameters for convolution, pooling, and flat. All these 3 we have now learned. Now let's take it from here to the next part. Now the next part that we would like to take through is basically from the coding and implementation part. Now we have one side we have seen theory about CNN, then we have seen about the visualization of it on the internet, about the hyperparameters, parameters, and the different functions. Third, we have gone back and we have seen, okay, if I'm going to use Keras, how does a code look like in terms of the functions, right? So let's see the next part. The next part is the implementation part. One second, I'm sharing the screen. Yes, okay, now I'll share it again. Participants, hope you are with me in the session. And you have any clarifications, please put it in the chat box. Now I'm sharing the screen again. Just confirm me whether you're able to see. Madam, sir, are you able to see the screen?
Yes, sir, it's visible.
Okay, fine. Now, see, once you have installed Anaconda in your system, right? So what happens is your Anaconda software is available. It would have got installed in your system. If you go here and type Anaconda prompt, you would get Anaconda prompt coming up on the list. So all you are supposed to do is go here, open Anaconda prompt. You will get your Anaconda prompt coming like this. Okay, fine. Now we have got Anaconda. Python is by default available. To check whether it is available, if you go and type Python, it will show you the version of Python. You want to come out of the screen, you can give Control Z. You can come out of the screen. You want to clear CLS. Okay. So once you install Anaconda, Python is also available. Now the next question would be like, we need some libraries because Anaconda doesn't have all libraries by default. So if your libraries need to be installed, you can say pip install. Let's take, we want to use matplotlib. Just go here and give pip install matplotlib. Now what it will do is it will connect to the internet. It will look for the library and it will collect the library and it will install it back to your system. Okay. So once installation is complete, it will show you that it is 100%. It is installed. Now if you already installed matplotlib, right? Then that case it will say that the requirement is satisfied. So the first command is pip install matplotlib for visualization purpose. Now to check whether matplotlib is working, what I can do is I can type Python. There I can go here and I can say import matplotlib, right? So within the code, it should say that it is accepted. If it's not accepting, then some libraries have not properly got installed. So let me go here, Control Z, CLS. Okay. Now first is we have tried with matplotlib. Then the next one that we need is we need Keras. So we'll go here and say pip install Keras. We go here and we will say pip install Keras. Now it will connect to the internet. It will install Keras to your system. If it is already available, it will say requirement already satisfied. Now I can go here and type Python. There I can go and say import Keras. Now it is not showing me any error. That means Keras is correctly being installed. So any library install, please come and I can type input library name. Okay, once again. Okay, now Keras is being installed. So we'll go back. We'll give Control Z. Yeah, so Control X. Once again. Yeah, it's come out now. So now what I need next is I need a TensorFlow. So I can go and say pip install TensorFlow. Right. So again, we connect to internet. It's already installed in my system, so it will say me requirement already satisfied. Right. Now, this is primary. Either you should go for Keras with TensorFlow or you should go for Keras with Theano. Right. As I told you, the other option is you can go for Theano also. Yeah, you can also install Theano also. Right. So Keras with TensorFlow, or you can go for Keras with Theano. This is also optionally good. The other one people generally suggest us to go for PyTorch. You can also go and install PyTorch, and that also is a good choice to work with the systems. Right. Now, Since you're going to go and work with more of image processing, you need the next software, which is OpenCV. So the next software that you need is OpenCV here. So you need to install OpenCV. So if I'm just showing so that in case you miss the step also, it's very easy. If I go and say pip install OpenCV-Python, it will just say this is a procedure for installation of OpenCV, right? So I have to go back to my command prompt. There I can go and type pip install OpenCV-Python. Pip install OpenCV-Python. Now this is also installed in my systems. So I believe it is there. Okay. So the softwares that you need to install is pip install Keras, pip install TensorFlow. The next one is pip install OpenCV-Python. Okay. Can you respond in the chat box? Somebody says yes, it's installed. Yes, something, so that we are all in the same stage. Participants, can you just put up in the chat box the software status? It's available. We are able to. Yes, sir, in process. Yes. Performing. Yes. Okay, fine. So it is in quick summary. You need to install 3 things. One is OpenCV. Then next one is Keras, right? And the next one is TensorFlow. The next one that you need to install is Matplotlib, right? I'm sharing the screen again, so I'll continue here again. I'm sharing the screen. Yes. Okay, fine. So softwares that you should have got is, you should have got pip install Keras, install TensorFlow. Next one is pip install Matplotlib. The next one is pip install OpenCV-Python. So these are the 4 that you should try in Anaconda, and you should get it ready so that your image processing program is ready to start running. Okay, right. I hope people are getting it. Now, assuming that everybody is able to get the environment ready, now let's go to the next part. Okay, so the next part of discussion would be is trying to take codes and try to make it working. Once Anaconda is installed, then what you can actually do is you can use any third-party editor. The third-party editor can be Jupyter also, right? So we go. So Jupyter, as I told you, it's a free software where you can actually run programs and you can work on your applications. And installing Jupyter is also very easy. Once you install Anaconda, Jupyter also will get installed, right? Now let's take through some codes and start understanding for today, so that we will have some things that you can try today at the end of the day and join for tomorrow's session. So when somebody wants to try something with deep learning, so this primary exercise that we start with is this one, Python code for minutes data set. Okay. So this code is a very primary code that you can see it in the internet. How to develop a CNN for minutes handwritten digit recognition. Okay. Yeah. So if you look at this code is very simple. This can be the first code for people to try also. If you can see here, first we want to use Keras, right? There you want to use minutes dataset. There's a predefined dataset that is being available. The next step is you want to load the dataset, right? For loading the dataset, there's a method called as load data. Minutes is nothing but the dataset name, right? Then next is we want to actually print the training values. And the next step is we want to print the test data. Then we want to plot certain images, right? And we want to show the final output. Okay. So there is also one more option for running your deep learning model, which is called as Google Colab, right? That also I will demonstrate it to you now. So once you go to Google Colab, you can actually click on the URL. It will be a web interface. The advantage of Google Colab is like whatever you want to work, right? Your codes will not run in your computer, whereas the codes will run in the third-party machine, right? Codes will run on the third-party machine that we are working, right? So let me take my one of the sample codes, which is being earlier done. So this is the Colab interface. This is my Google Colab interface, and it will be authenticated with my email ID. Right. Once you go to Google Colab, it will ask you for your email ID also here. Right. So here as such, if you look at this here, what we have done is we have got a set of data and we have tried some models. This will be the user interface, right, of Google Colab. Now here I can go here and I can click run all. When I click run all, what it will do is it will start running the code from the beginning. Right from the first line, it will start running the code. Now, please understand, now the code is not running in your system. The code is running in the Google server. So there is no worry from your side that your system will get spoiled, will get crashed. All such things will not happen in your case. Okay. And the code will run from beginning to end. The code will run from beginning to end. If there's any error in the code, then that error will come up here at the bottom, right? Now let's take our new code file. So I'm opening a new Python notebook file. Okay, so I've opened my new Python notebook file, and let us take the code that is available here. I can go here and I can copy the code part. Yeah, copy the code. Now I'm coming here. I can paste the code. Okay, so once I pasted the code, what I can do right now is I can go here and I can rename this file. You can see here, no? Rename this file. My first example. Okay, now I can go here and I can run. So I'll go here and run all. Now the code is trying to run. Same way, you can also start doing participants. You can open Google Colab if your Anaconda is not working. Now, as it is trying to run, you can see here, it has first downloaded the data from the minutes dataset. Okay. Then next, what I want to do is I want to print the values with respect to training and testing. So this many samples it is taken for training, right? This is your sampling time with respect to testing, right? So next, what it does is the train values is this. It is 60,000. Size of the image is 28,28. Similarly for testing, 10,000. Size of the image is 28,28. And this is values with respect to Y. Okay. Now it is taking all the images, right? Then it is showing the image plot here of the images that it has recognized. Okay. So this is a very primitive code for handwritten character recognition. As you can see here we are using examples in the training, 10,000 examples from the testing, and the image size is 28,28. So that is why it is showing you X as 60,000, and for the testing it is showing us 10,000. Okay, and here when you want to do the plot, we are plotting for 9 images. That is the first 9 images alone we are taking the plot. The first 9 images is taken and the plot is being shown here. Right. Now the next set of steps would be is like we will be interested to actually have a model. We'll be interested to evaluate the model every time for recognition. So here when we want to load images, as we told you, we need to load the images separately for training, and we need to load the images separately for testing also, right? When we want to load the images for training and testing separately, we can load it and we can reshape the images also. What is the purpose of reshaping is, in case the image is not having a size of 28 cross 28, then I can reshape the images to the size of 28 cross 28. So that can be done by using this method called as reshape, right? The next is, if you want to convert every class value to a categorical value of 0 to 9, that can be done by using this method called as toCategorical. So when we say toCategorical, train y equal to toCategorical of train y, we are converting it from to values between 0 to 9. Similarly, test toCategorical of test y, we are converting it to values of 0 to 9, right? Then next same steps, we are loading the data set, right, with the same minutes data set. Now the difference in this code is we have reshaped the data set to fixed size of 28,28. We have converted to categorical value of 0 to 9 by using toCategorical method. Okay. Now sometimes what happens is it is required for you to normalize the values also. Right? It is required for you to normalize the pixel values, especially by modifying the grayscale values and reshaping them back to 0 to 1. So there you can actually use this method called as train underscore norm for training normalization and test underscore norm for testing. What is train underscore norm is whatever value that we got originally in training earlier, this will be between 0 to 9. Now I can convert it to float and then I can normalize it to 0 to 1.
Yeah.
The next is I can actually use the next method called as trip underscore pixels. This is a user defined method as you can see here. Now this method, what will do is whatever we have shown till now, it will actually do it as part of the method. It will take the categorical data, convert it to float, and then normalize it to values of 0 to 1. Okay. The next is creating the model. As we told you, when you want to create the model, we will have to use the layers. So here you can actually use your pooling layer, right? And you can support with your respective activation functions. At this point, it is important to speak about activation functions. There are linear and non-linear activation functions as part of deep learning here. Normally, neural networks has got linear activation functions, but when you come to deep learning, it's got non-linear activation functions. Okay, fine. So here, non-linear activation functions, why it is very important is is more relevant to saying that I'm using nonlinear kernels, right, for the models, right? So deep learning has got a lot of nonlinear activation functions. Here, example is ReLU. The most common nonlinear activation function is ReLU function. The next is the model evaluation process. As I told you, we would like to evaluate the model by taking a training and then followed by testing, or we can use cross-validation procedure. Most of you know what cross-validation is in terms of deep learning. Same concept here. You can use cross-validation procedure here. Here we are using a k-fold cross-validation, right? And next thing is to be understood is the training and testing procedure. So here you can create your model by using a method called as define_model, right? Then you can actually take the data for training and testing, right? So that we would take it from the training values and testing values that we have earlier provided under data X and data Y. What is data X and data Y is, if you can see from here, you will find, yes, you will find your parameters for data X and data Y. Yes. So you will take your parameters from data X and data Y, and that will become input for evaluating the model. I'm talking about this part, right? Okay. This is becoming a parameter for evaluate model here. Then you can fit the model, you can evaluate the model. Then once it's all done, you can prepare the results and you can present it. This is a small code which actually runs for this. Now we can actually take the complete example for each of this. First one, you need the code for training and testing. Okay, so data set is going to be same minutes data set, right? And next, what we have is preparation of pixels, defining the model, evaluating the model, then running it and seeing the results. Now what we'll do is, you can, all of you please follow with me. Please take the code, copy the code. You can go here, you can go and create a new Python notebook file. Go here and create a new Python notebook file. And in this Python notebook file, you can actually go here and rename it. Rename the Python notebook file here. So the Python notebook file can be renamed as my example2. Okay, my example2. Go here, paste the code. Right now, you can go here, run all. Now what happens is the code will run from beginning to end. Okay. The code will run from beginning to end. It's on the same minutes data set, right? And it will set all the hyperparameters, and finally it will show you the results. So the results that you will be getting is all these results. Here, the first one that you will be getting is all the accuracy parameters. Then the next set of plots that you'll be getting is the cross entropy loss, then accuracy curve, right? All that you'll be getting here. Let's see here, it's running. Yes. Okay, you can see here the code is started to run. It's taking the data set, right? Then once it has taken the data set, it will start going for step by step. So first step is it is now loading the data set. Then second step is it will prepare the pixels. Okay. Third step is it will run the model and it will evaluate the model. Third step it will be is it will run the model and it will evaluate the model here. You can see here the results. Okay, the code is running. Now starting with the data set, it will run for some time. How many of you are able to get this code running? Can you put up a hands up symbol, or can you respond in chat box, participants? I'll come back to K-fold. Valid question. What is the purpose of K-fold? I'll explain you that. Participants, can you put in the chat box for how many of you the Google Colab, the coding is starting to work? I'm getting stage by stage because tomorrow it will go to the next level of where you will modify a existing code. Working with this example, okay. Others, I think each one of you have an internet and a system and a Gmail account, can open Google Colab and you should be able to see the output. Okay, it's working. It's working. One of you, please, can you acknowledge in the chat box at least? Participants, are you able to see the screen? Please acknowledge.
Yes, sir. Yes, sir.
Yeah, okay, fine. So it will take some time, but don't worry, it is not your computer's memory getting exhausted, it is Google's server. So other advantage here is, when you work on all the deep learning implementation, the next question somebody would start asking you is, did you try porting the code with GPU? So if you have GPU based code also, that also you can run it in the Google Colab. Okay, that's the biggest advantage of Google Colab. So you need not have your system with GPUs. You can run your code which are GPU based also on Google Colab. Okay, then any questions that's come up? Okay, yeah, one question that's come up is like, what is the purpose of K-fold, right? Okay, that's okay, valid question. See, actually, when we say that when we have created a model on a given data, it means that the model is running for many number of times on the given training data, and it comes back with a best model. That means it is running for sorry, it's running for more than one epochs, right? If you don't give a K-fold, what happens is it will run from one epoch to another epoch and so on, and it will finally create a stable model. But instead, if you would like to create a model where every time you want to give a data and you want to learn the loss values, based on the loss values, you want to come up with a possible best model, right? After iteratively doing one by one, you can go for a K-fold approach, right? The theory goes very simple. Like if you go to machine learning, we would say that if you have a data set, you will note the data set. For each of the data set, you will try to train with the test scores, right? So once we get a score value, we will choose one which has got the lowest score value, and then we would like to create a model again. The same procedure is what is followed for K-fold. So if you have a data set, please, you can run through a K-fold approach, and then you can actually do a classification. Hope it is understandable, sir. Understandable. Prashanti Bhaskaran, I think, has asked this question.
Yes, sir.
Okay, fine. Okay. Right. So I think the code is running on one side. Let this get on going, right? Meanwhile, we will come to the thought process of security in images. What do you talk about security, and how do you actually secure images? Because I'll share you an example at the end of the day so that you can try it and join for tomorrow's session. So when you look at security in images, what are all the possible ways, right? Let's see here. One is like face detection is a common problem, right? Where security is very important. So I have given a title as secure network. What I mean to say from here is, if I have cameras and the cameras are going to capture the data, and the camera capture data is going to give something about my security. I feel that my network is secure. That's a thought process. So if my cameras can actually capture data, and if they can say which is right face, which is not a right face, that means person X and Y alone is supposed to be in the building, and there are some other persons called as W and Z, right? That is an example of a face detection problem, which you can take it with respect to security. So in our thought process also, we will also look at face detection in the forthcoming sessions. So there, the popular example algorithm that is available is called as Euler-Jones. The popular algorithm for face detection, especially with respect to security, is Euler-Jones. Here also we have code for Euler-Jones algorithm, which is available with Python. Okay. So here you can look at security in terms of images. Given image, trying out a face detection, and say that this person faces X, this person faces Y, and so on. This is first with respect to face detection and security. The second aspect of security would be is wherever you are looking at possibilities of people having any sort of objects which are basically not a regular object but suspicious objects. Like somebody, let's take a student is sitting in a class. I'm just saying an example. Packet. A student is having a knife in the packet. Just saying an example, right? So I want to have this object, a regular object or a suspicious object. So all that will go into something called as hidden weapons. Nobody will keep an object which is suspicious. That's an outside object for everybody, right? So if I have some hidden weapons, like for example, I'm showing you here, no, maybe a hidden weapon, and this objects be recognized by using my deep learning model. So there, the need for security also comes up there, right? So that is second place for security. The third place for security that is becoming very popular is basically or actions which can be understood as suspicious, right? So I would actually say it like this: suspicious activities of humans. Suspicious activities of humans. So this suspicious activity can be anything. Somebody is just moving left and right. Somebody is walking uneven. That is also a suspicious activity. So can I recognize such suspicious activities? Which I can say there is a chance for providing security in my system. So that is next one that you can think of. I'm talking about what I know. The next would be like possibility of emotions which can be detected, right? Which is also a possibility to say that there is a security issue. A person's emotion is uneven, in the room is even not having an emotion. So that person will become a suspicious person. Try to reduce the security of the context, that is the building or the room. So these are the spaces where security can be thought of, right? So today's session, we have set you a stage where you know about CNN, principles of CNN, and then we have told you about how to take a code which is on the internet and run through a code which is basically for MELTS dataset. So the forthcoming sessions, we will look at the directions which we have pointed to you, that is face detection, suspicious activity recognition, hidden object recognition, as a space to say that there's a need for security to be enhanced in any environment, right? So that's what we will try to take it in the coming sessions. Any questions from the participants? With this, we will close for today's session. Any questions from the participant side? Okay, yes, sir, it's working. Hemalata, ma'am.
Sir,
Yes, ma'am, please.
sir, for multi-class feature extraction, how could I perform that, sir? For I'm using in medical data
Okay.
and I'm working on it. Like if I'm going to try to capture multi features, after that extraction, should I pass the inputs to the CNN layer, or like it should be in separate feature selection method? Sir?
Okay, fine, ma'am. It's a very valid question. See, one way of approaching deep learning is give the image features will be learned as pixels. The CNN will actually approximate with a class score value. Other possibility is you introduce a layer for feature extraction, and that layer will extract the features as user-defined features in the context of the problem. For example, like if I'm interested in taking a medical image, where I'm interested in finding out regions which are circular, and again in circular I would like to see circular features with dimension 0.5, 0.25, 0.01. There are three features which is 0.01, 0.25, 0.1. So all the three features, if I need to extract, I need to write a feature extractors. That becomes one of the layer there. There, once that is being extracted, then I can actually give it to a k-means clustering, which will cluster and say how many clusters of each of these features are available. Then I can actually directly give it to the fully connected layer, and I can get the closest score value.
Okay, sir. Thank you, sir. Yes.
Yeah. Yeah. Raw data sets, yeah, is there for object detection, ma'am. Yes. Is there any data sets available for in vitro filtration technique for birth occurrence? Maybe that I will check with my friend who is a doctor and say you. Maruti ma'am's question I am not able to understand. Kindly use raw data sets for object detection. That means, ma'am, I am not getting. Maruti ma'am.
Sir, for detecting the object, we use a video, sir. From that video, we getting some data, sir. For that, how we want to do labeling and how we want to do detection for that, how to write coding for that, those things I am asking, sir.
Okay, see ma'am, actually the input video that you specify actually is again set of images which are having some sort of objects, right? So for example, the context, what context you want to take an object?
Sir, I'm trying underwater images, sir.
Yeah, if you are looking at
there is no lot of data sets.
Correct. So actually, in image processing, one possibility is you should go for data sets which is available as benchmark, like Caltech data set like that, or you have to do crowdsourcing, right? Crowdsourcing in the sense, if you happen to know a person who is in oceanography, they would actually work on underwater data set. They might not have captured data sets like what you are asking, but you can request them to get such data sets. So in your underwater, what you mean to say is you are creating a shallow water bed, correct? Which is
no, sir, deep water.
Okay, deep water bed. Deep and shallow, again the turbulence of water alone changes now. If you're going to simulate, it's going to be a deep or shallow, its turbulence of water alone changes.
Yes,
sir. No problem. Shallow or deep water bed. The type of objects you're going to look at would be you look at greeneries, rocks. Is it like that?
Yes, sir.
Yeah. So if you're going to look at greeneries and rocks, I'm just saying from thought process. The rocks as such, you have a lot of data sets on the internet for rocks, correct? Small stones to big pet stones.
Okay, sir.
Obviously. As far as greeneries are concerned, you will not get greeneries of how it will appear within the water.
Yes, sir.
It is not possible. But as you have greeneries in the open sky, and you have greeneries which are watered, you have rain and you have greeneries getting watered, such images can be cropped and you can call it as your own data set. In fact, that is also possible. Since you have asked this question, we told Kaggle you can use data sets from Kaggle, right? But it is also possible that if you are doing a research and you happen to create your own data set with whatever you have, you can actually log in and you can post your own data set there. We can call it as an underwater data set.
Yes, sir.
There the advantages people will start using. Maybe there's a possibility for you to go get more results. Now, actually, I am associated with one scientist in oceanography department. What we are doing is we are set up of an aquarium of 3 feet to 3 by 3 feet. Okay. And 1.5 feet depth. So there we are trying to have cameras and capture the data. So there we will surely have some stones, small greenery part, and see how the fishes move around in the water. The thought process about how to monitor fishes and how the quality of water changes with the movement of water, movement of fishes, right?
Okay.
That time maybe I'll surely try to give you some data sets. That I can give you commitment now. It's not a problem.
Okay, sir. Thank you, sir.
Yeah, thank you. So any other questions for today? Okay. If there's no questions, my request to the participants would be like get familiar with the Google Colab. And tomorrow's session, we will start again with the code. We will share you the examples. I will also share you one manual that will be shared by the organizer tomorrow morning that you can practice and join for the tomorrow's evening session. It's just to give you a learning more on the concepts that we have done. That's all for today. And there's no questions. Only one question with respect to medical. I don't know. I will check it and get back to you. Like that question alone, I will. Yeah. This question from Saranya Murli ma'am. I will check and come back to you, please. That's all from my side for today. And thank you again for your patient listening. Thank you, participants. Madam, thank you, ma'am. Thank you.
Yeah, thank you, sir. Thank you so much for your in detail explanation of how to start with an implementation. Thank you so much, sir. And we are waiting forward to listen to your tomorrow's session.
A pleasure, ma'am. Pleasure.
Yeah, thank you, sir. Thank you so much.
Thank you very much, sir. Thank you very much, sir, for your knowledge sharing on deep learning, feature engineering, architecture of CNN algorithms, parameters, and hyperparameter tuning, Anaconda, OpenCV, Colab, etc. So with this, we are winding up today's session, and we request the participant to join for tomorrow's session from 4 to 5:30 p.m. in order to acquire more insights on deep learning technique. Thank you.
Thank you, ma'am. Thank you all.
Yeah, thank you, sir. Thank you so much. So dear participants, fill in the feedback form and join with us tomorrow to get more insights on the secure network analytics with deep learning and transfer learning. As sir told, he will be sharing many of the examples also. So don't miss it. Thank you all.